So, good morning, everyone. Thanks a lot for invitation to this event. So, I am Pierluigi Leone, and I'm professor at the Department of Energy of Politecnico di Torino. We work on, let's say, we do studies about hydrogen integration into the energy system. That, especially for us, it means to look at understanding use of hydrogen in final sector, also through energy system modeling, and also look at infrastructure for hydrogen transport and distribution. We are also involved in some international activities. Here I wrote hydrogen diplomacies, maybe this is too much, but by the way, we are trying to to look at what is going on in regions that could be, are important for hydrogen, have complex energy situations, and which could be even in the next future, have stronger relations with EU. So I am talking especially about Africa, and I'm talking especially about Central Asian countries. We are involved in three main projects. So the results that you will see, the considerations that you will see in the next slides are mostly based on these studies. One is a national project. It is called NEST, and then there are two new projects. One is about hydrogen network. It is called Shimmer, and the other one, which is called Shamrock, is actually an hydrogen valley which is developed in the Ireland. So today I will try to share perspectives on three main points. The first point, so we will talk about actually energy network, energy infrastructure. So the first consideration, the first part will be about trying to understand, or at least thinking a bit more, what does it mean repurposing of natural gas infrastructure to switch to hydrogen transport. The second part is especially related to a technical assessment of the European hydrogen backbone, especially for a country like Italy that is going to be a transit country for hydrogen with respect to the rest of Europe. And the other point is that, according to our opinion, there is, a right focus, of course, on national backbones, but according to our opinion, it could be also interesting to look at a sort of parallel development of regional networks that, for example, could be further developed around hydrogen valley. So let me share with this. As we know, it has been already mentioned this morning in Europe, there is this important initiative about the European hydrogen backbone. It is expected that around 60% of total hydrogen that Europe is planning to import will come through pipelines, and in particular through 5 corridors. Even for the remaining part of hydrogen which will be imported, and the part which will be locally produced, of course, the pipeline system is fundamental. It is also expected that most of these European backbone should be based on repurposing of the natural gas infrastructure. So there are the different European countries in this respect have different roles. So here we try to summarize only some of them. For example, Italy would be a gateway with North Africa, but it will be mostly a transit country, since most of the imported hydrogen should flow finally to other EU countries. Spain should be a main exporter country, meaning that the local big production should help other European countries which are expected to consume a lot of hydrogen. For example, Germany, no, which is well known, should be the main hydrogen consumers in Europe. So when we talk about, we think that when we talk about European hydrogen backbone, of course, the different roles that the countries will have in this perspective as exporter, consumer, and transit countries, of course, will have some impacts in the technical side, but also in the policy side. So first of all, I want to share with you some consideration about what does repurposing means. Often, usually when we talk about repurposing, we are talking about the possibility to switch some pipelines, some natural gas pipeline to transport hydrogen. And this is, let's say, mostly feasible in countries where there is a redundant infrastructure with parallel lines. So, for instance, here we were analyzing the gateway, the gateway of the South H2 corridor, which is Sicily, where there are two import points from Libya and from Algeria and Tunisia. And as you can see, there are some parallel pipelines that in the future could be splitted. One pipeline, let's say, dedicated to hydrogen, that should go then upwards through all the peninsula. And then the remaining part of the infrastructure still serving for natural gas supply, especially in the transition period. So, of course, it should be important that this infrastructure should, for a certain period, coexist in some way. So, for example, here we did some simulations. So this is just fluid dynamics simulation about this network. So in the extreme left hand side of the screen, you can see how the actual network is operated now with typical pressure and flow velocity. Then one option that is about blending. So it means just mixing hydrogen with the natural gas and then using, let's say, the same infrastructure, more or less as it is. And then also we did here the exercise on the right-hand side to split the actual network and to use one pipeline for just transporting pure hydrogen and the other pipeline just to transport natural gas. As you can see here, we have data about pressure. In particular, in the hydrogen backbone scenario, you can see that we reduced the hydrogen pressure to be compliant, let's say, with embrittlement, material compatibility of the infrastructure. On the other end, we increased the operating pressure of the natural gas remaining infrastructure in order to, let's say, boost at the maximum capability the natural gas infrastructure. So some aggregated data can be seen in the next slide. So, well, hydrogen blending for sure will give only an incremental contribution for hydrogen transport. So we estimate only around 0.7 million tons per year transported. This is already a 20% in volume of hydrogen transported there. And also we see already quite a very high velocity in the pipeline, almost approaching the limit, which is set at 25 meters per second. On the other end, the hydrogen backbone, as you can see here, we can transport, of course, much more hydrogen. Also in this case, we reach, as you can see, quite high velocities in the pipeline. And on the other end, of course, the throughput that could be achieved by the reduced natural gas grid is much less. It's 15% less in terms of energy, which of course means that in some way other supply should be guaranteed for the nation, or that of course demand should be reduced. No, this is also sound because some demand should switch to hydrogen, but by the way, there are these conditions that can take place. Another more extended analysis that we want to share is looking at the whole hydrogen backbone, at least for the Italian side. And we want to concentrate here to the role of transit country that Italy should have. Transit country, it means that in some way the infrastructure should be so robust to assure that the supply will reach, let's say, all the countries, all the other European countries which are in this corridor, that is Austria and other countries, but especially Germany, of course, that finally are will be dependent on this supply. So even in this case, we set one scenario, which is a scenario quite simple, but just to show some kind of results and consideration that can be done on that. So we set some scenarios for import from North Africa. We set some local production, very small local production. This is a scenario that should in some way reflect the 2030. So let's say 5 years from now. And also we estimated some demand. Some demand, it's concentrated, especially this is demand for hydrogen as a feedstock. So we are talking about primary steel. We only have one plant in Taranto, potentially. We only have a potential plant in Taranto. Then we have one plant for ammonia, and we have 11 refineries that are considered in this study. And in particular, you see here there is an important cross-border flows. You see most of the import actually is exported, no? At least in this short-term scenario. So this study in particular is concentrated in this part. So you see, we analyzed two setups, one with 3 compressors, which are large, long-distance compression units, and another scenario which with the short-distance, smaller compression units, so 9 units. So these compressors more or less are placed in places where today the compressor for natural gas are already placed. So and here we can see some results. We did some design of this network. So estimated maximum operating pressure to avoid embrittlement. We also set up some pipeline diameters, of course, based on the indications already included in European hydrogen backbone data, but in other cases, in particular, we realized that the pipeline connecting the border between Italy and Austria should be a bit expanded in terms of diameter in order to match the expected exported flow of hydrogen. And here you can see, I mean, some results in terms of pressure, in terms of velocity. So with actually with the 9 units compressors, we had smaller. We have overall we have a smaller compressor power needed. I mean, it is, of course, it seems more feasible to operate the network in this condition, even because the velocity is well below the 25 meters per second, which is set as the maximum threshold for velocity. Of course, 9 compressor means in some way more maintenance. So, you know, operating cost maybe is compensated about maintenance. Last part to close, because I am almost finishing my time. So here I want to offer another perspective. So, okay, the first 2 slides, there is the backbone. No, so with their technical characteristics, with some considerations that should be done about the transit country, consumer country, and so on. But I want to offer here another perspective about about the development, the potential development of regional hydrogen networks that could be established around clusters of off-takers, and that in some way can be developed in parallel with the national backbone. So here we just did an analysis of clusters in Italy. Cluster classified, sorry, according to different criteria. So here on the left-hand side, you can see a cluster with the very large high temperature heat consumer off-taker. So you can see some clusters here near Modena, Bologna, in the central part, where there is a ceramic industry. Then near Lucca in Tuscany, I hope you can recognize it. There is a very big district on paper. And then on the northern part, it is the secondary steel. So it will be actually high temperature heat supply. So here the idea is that you see some of these clusters some are close to the backbone, which you can see in green line, but some of them are not so close. They have also a relevant potential for hydrogen uptake. You can see from 10 to 30 kiloton per year of hydrogen per each cluster. So it could be worth to explore the possibility to develop regional networks. We think that hydrogen valleys can play an important role for this. So far, hydrogen valleys have been promoted by European Union, especially to boost, to stimulate the demand. But we think that especially large hydrogen valleys or scaling up hydrogen valleys can in some way even boost the development of these regional networks. And we think that this could be highly beneficial even for the risking investments in for the big infrastructure, for the national backbone. So here there are some conclusions. We think that when we look at the backbone, either the policy implications for different countries should be considered, and also the technical layout, of course, is important to study in order for each country to guarantee its role in the whole European framework. But we think some countries are quite advanced, for example, for regional networks like Germany. Other countries like Italy, for example, are very late, quite late, but Italy is not the only one, about the development of regional grids. We think more effort should be put on these two sides. Thanks a lot.
Thank you very much indeed, Professor Leone. I think just we've caught up some of the time, and I think if we can catch up a bit more, that would be good. So please put your questions to Professor Leone. I know I have a couple